Hello and welcome to my channel. Today we are discussing a very interesting topic: osmolarity versus osmolality and versus tonicity. So let's start. Today we will discuss the following terms: molality, osmosis, osmolarity, osmol and tonicity. So let's start without wasting our time. So first of all, molarity versus molarity. If we look at the definition, molarity is the number of moles of solutes per liter of solution, and the unit per molarity is capital M. Whereas molarity is the number of moles of solute per kilogram of solvent. The unit of molarity is M. So if we look at the key differences here, the first difference is that in definition of molarity, we will look at that the number of moles are same in both, but where it is present and how much solution it is present. So in case of molarity, it is present in per liter of solution. Here you can see per liter of solution, whereas in case of molarity, it is present in per kilogram of solvent. So in first case, the solute is present in liter of solution, means that you have to calculate the volume and then look at the number of moles of solute in that volume, whereas in second case you have to calculate the kilogram, kg, and the kg of solvent. You have to then look at the number of moles of solute. So the key difference is, in case of molarity, if you look at how will you differentiate the common mnemonics that are used nowadays, is that in liter you can see the letter R, whereas in molarity R is present, so most of the people remember it by this way, by pronunciation molarity and later. So in both conditions the R appears, so that's why most of the students remember it by this way. So if we look at the units, moles per liter, and commonly denoted by capital M molarity, whereas moles per kg and commonly denoted by small m. So this is the main difference. How we will calculate the number of moles? So it says a very common formula: mass in gram divided by molecular mass. For example, if you want to calculate number of moles of a molecule like NaCl, so number of moles can be calculated by, if we are given mass in gram, and then we can calculate the number of moles from it by finding out the molecular mass of the molecule. For example, if we are given NaCl is given, so sodium and chloride, so sodium molecular mass and chloride molecular mass both are calculated, and they are then added with each other, and after that mass in gram is given. Mass in gram is divided by molecular mass of both sodium and chloride, and by this way we get a number of moles. So for example, if you want to calculate molarity, it will appear like in this example: a cup of tea is present, and you want to put sugar in this cup of tea, and this amount of tea is given in liter. So in this case you will put a number of spoons of sugar in 1 liter of coffee, whereas in this case, in case of molarity, you will put number of spoon of sugar in kilogram of coffee. So the most commonly and most practical unit is molarity. You can use it commonly, whereas molarity is not so common. Whereas if you look at the accuracy, so molarity is more accurate as compared to molarity. We will discuss it later. Now we come toward osmosis. We have learned in our previous classes that osmosis is the movement of water molecule from higher concentration toward lower concentration across a semi-permeable membrane. So if you look at this figure, here you can see three diagrams are given. In the first diagram, water is present at the both sides of this tube, and there is a semi-permeable membrane in between it. In the second figure, when sugar is put on one side of this tube, the water will flow from this side, and it will move from this side toward this side. So this shows that water here the concentration of glucose molecule is greater. That's why the water molecule will move from higher concentration toward lower concentration. Here the water molecule is in higher concentration, where here and the water molecule is in lower concentration. So these water molecule will move from this side toward this side, which shows the osmosis, which is clearly depicted in this diagram. So water will move to follow the solute, and this will be the osmosis. So this is a practical example which shows that in osmosis the water molecule moves from area of high concentration toward the area of lower concentration, or you can define it in another way, that the water moves from area of low solute concentration toward a high solute concentration. So both these examples we have discussed. And now if we look at osmosis, it's a simple diffusion of water, and it always occurs from higher water concentration to low water concentration across a semi-permeable membrane. So what is do you have to remember one thing, that osmosis is a passive process, means that here energy is not required to for the movement of water from higher concentration toward lower concentration. Now what is osmotic pressure? Osmotic pressure is the pressure needed to stop osmosis. You can see pressure is denoted by phi, whereas n divided by v. Here n shows the number of particles and v shows the volume. This volume can be calculated by n liter. So what is osmol? Osmol is the osmosis caused by 1 mole. Osmosis caused by 1 mole. This is known as osmol. Osmolality, the amount of force per volume measured in milliosmoles per kilogram. Milliosmol is 1 by 1000 of the osmol. 1 by 1000 part of the osmol is known as milliosmol. 1 by 1000 part of the osmol is known as milliosmol. So osmolarity is the amount of force per volume measured in milliosmol per kg or millimole per kg. Osmolarity, the amount of force per volume measured in milliosmol per liter. So the key difference is the amount of solute and the amount of solution. The amount of solution when measured in kilogram, we refer it as osmolality. When the amount of solvent is measured in liter, we call it osmolarity. So this is the minor difference between both these cases. Now if we look at which one of the unit is more accurate. So the osmolarity, this is MCQs, that osmolarity is the more accurate unit, because weight does not change whereas osmolarity is not so accurate, because if you heat the solution it will expand and its volume will increase. So change in volume will take place, which will decrease the osmolarity. So with heat osmolarity will not change. Whereas in case of osmolarity, when you heat the solution the osmolarity will change, and hence it is not so accurate as compared to osmolarity. If we look at which one is the more practical unit, yeah, or we can say which one unit is most commonly used. So the most commonly used is osmolarity. If a doctor call you and tells you to bring some sample of blood, and you cannot bring it the sample of blood in kilogram, you have to bring him the blood in cc, either cc or ml. So in this condition the practical unit that is mostly used in our daily life is cc or ml. So osmolarity is the more practical unit, or osmolarity is not so practical or not commonly used, but both of them are mostly used interchangeably. Now if we revise what we have learned, osmotic pressure is determined by number of particles in a solution. Size doesn't matter, neither does shape or charge of the molecule, only the number of molecule matter. As we know that 1 mole of any particle, 1 mole of any molecule contain Avogadro number that is 6.02 multiplied 10 raised to power 23. So these are the number of particles which we are indicating. So number of particle matter, if there are 2 mole, then the value will increase to 2 multiplied 6.02 multiplied 10 raised to power 23. So number of moles matter, not number of particles. Osmotic pressure, or an osmol, is the number of moles of solute that contribute to the osmotic pressure of a solution. That is known as the osmotic pressure. We have discussed it earlier. Osmotic pressure or osmolarity refers to concentration of all particles that contribute to osmotic pressure. How can we calculate osmolarity and osmolarity? We can calculate osmolarity from osmolarity by this simple formula. But if we know the osmolarity, we can simply multiply it by 0.995, and hence we will get the osmolarity. If we look at the human intercellular fluid and extracellular fluid, their osmolality may range from 275 to 295 milliosmol per kg. So this is the machine which is used for measuring osmolarity. Now if we come toward our last topic, that is tonicity. Tonicity shows us the effective osmotic gradient across a semi-permeable membrane. For example, if we have two different condition and we want to separate it by a semi-permeable membrane, so the osmotic pressure present here we can denote it with A, and the osmotic pressure present here we can denote it by B. So the difference between the osmotic pressure of A minus B is known as tonicity. So tonicity can be measured by the osmotic gradient between 2 points across a semi-permeable membrane. On the base of tonicity, a solution may be hypertonic, or isotonic. Hypertonic means that that solution have higher concentration of solute, whereas hypotonic means that this solution have lower concentration of solute. Isotonic means that the number of solutes are same across both across the semi-permeable membrane. So in a first diagram, if you look at here, a cell is present in a solution, and this solution has more solute as compared to a cell. So this cell is hypotonic as compared to this solution. So in this case, the water will move out from the cell and it will shrink or crenate. Whereas in second condition, if you look at this diagram, a cell is placed in between a solution. Here the number of solutes are more in cell inside the cell as compared to outside environment. So water will move from higher concentration to a lower concentration, and in this case the cell will swell or burst due to movement of water molecule into the cell. So if we look at the third diagram, here the water molecule are almost the same, and the solute molecule are also the same across the membrane, across the cell. So in this case, the amount of water entering the cell will be equal to the amount of water going out of the cell. So that was all from our today's lecture. Here we explain all the topic in detail. Thank you very much for listening.